Assalamualaikum guys. I think we will start our today lecture. First of all, uh, my voice is clear.
Yes, yes, Mr. Z, your voice is clear.
Okay, thank you. Okay, so today our lecture is regarding the string sizing from LVDC cable sizing. So both are interlinked with each other. So that is why I have planned that I will cover these two topics in the one lecture. And at the end of the class, I will take the question answer from everyone. Uh, so if you have any question, you can write in the chat box. I will see at the end of the class and will answer all of your questions. But for the at the end, we will see the uh, all questions and answer. So now I am starting my lecture. I have just explained in the first lecture that how we will calculate our cable sizings. First procedure is to verify the cable derating ampacity with the load current, and then the second procedure is to check the voltage drop limitations as per the IC standards. And I have tell all of you that as per 62738 IC standard, the voltage drop limitation for the string and LVDC. So they don't mention anything specially. They just mention the DC voltage drop. It is around 1 to 1.5%, but on average basis, as clearly mentioned in the IC standard. So you should write down these IC standards 62738. So now I am moving to my lecture. Mm, can you see the screen? Can you see the
Yes,
screen?
yes, yes, Mr. Z.
Okay, thank you, thank you. So I have prepared the Excel sheet part, which I have prepared for the yesterday portion, which I regarding the LVC. Now I have prepared the two other parts. One is the string cable sizing, and the other one is for the LVDC, but in the different sheets. So we just discussed the first portion, the DC string sizing. So as per the IC standard 62738, in that they have clearly mentioned that as per IC standard, they clearly mentioned that IC 62738, it is clearly mentioned that the load current, the string sizing current, the DC current, which we have to check with the derated ampacity. It should be the string current, string current, including including bifaciality if it is bifacial PV module plus the 25%, sorry, 50% extra margin for the string cables. So it is clearly mentioned in the IC standard that the string current, including bifaciality plus 50% extra margin, we have to check the derated ampacity with this value. With this value. So if the derated ampacity not satisfy this value, That means the cable is not satisfying the criteria of cable derating capacity. So you have to so you have to check this very carefully that I have prepared one sheet in which I have mentioned the PV module data, in which I have mentioned the PV power, power voltage VMPP, open circuit voltage, maximum power current IMPP, and the short circuit current. But this class is for the short circuit current, short circuit, not the operating. So I have mentioned the power. The standard test condition power is 610-watt PV module Trina. I have this that from the Trina PV module data sheets. The VMP is 39.79, VOC is 48.09, the IMPP is 15.33, and this ISC is 16.14. They have the standard test condition values. And as per the 5% bifaciality, these value become 610, 640 power, 41 power. Voltage remains same in both cases. And the current will increase 15.33 to 16.10 and 16.95. And with the 10% bifaciality, it will become 671. VMPP same, open circuit remains same, and they become the 10% including bifaciality. So so we have to apply the formula, apply the because you know that in the string there are the like 29 PV modules. I have just mentioned above this one. I have mentioned that the PV module per string 29. So they are in the connected in the series. So the current for the series remains same. So the one PV module current is the overall string current. So the maximum current short circuit is 17.75. Bifaciality it will be 10%, not 5%. Plus 10%, plus 10% bifaciality. So so I have checked that criteria because in this the bifaciality is already included. If we take this standard test condition short circuit current, then we have to multiply our uh, plus 10% bifaciality and 10% plus 50% extra margin. But in that, the bifaciality current, they already included the 10%. So that is why I have taken this and apply the 50% extra margin means at 1.15. So that is mean that it is 150% the current. So our our criteria become 26.66. So now we shall check that I have prepared a Excel sheet in which I have given the cable data. This value R20 is basically we get from the vendor, and R25 we have to check the IC standard, IC 60287-1-1. This is basically the IC standard. This is IC standard. So we have to check that, and in that they have given us the uh, other than 20 degree temperature, other than 20-degree temperature, we have to calculate the DC resistance of the cables. So in that case, we have some ambiguities. We have some ambiguities. As per my experience, we have satisfied this criteria R25. But I have seen that some of the cable calculator, they will use the R20. Some of the consultant will raise the concern that we shall use R25 or R90 because 90 is the maximum temperature of the cable. But if we use, here is the 90, that is the formula. If we use the 90-degree, the cable resistance will increase too much on the higher side, and no cable voltage drop will satisfy. So that is the reason. That is the reason we have in in my experience we have disconnect. We have discussed with the consultant, and they accepted this criteria R25 because 25 is the standard test condition of the PV modules. At that, we have the maximum values. So that is why I R25 I have calculated from this standard IC 60287 1 1. I have calculated this R25. This value R20 I get from the uh, vendor data, and also the IC. This standard. This standard also give us the DC resistance R20. So I R25 I have calculated from that. The coefficient, because they have the formula basic R20 resistance multiply with the 1 plus coefficient. This coefficient alpha 20, this is the coefficient, multiply with the base temperature on which we are calculating, like 25 minus base temperature, which is 20-degree. So that is a simple formula, and this also is mentioned in the table, I think table 1. I think table 1, they this coefficient is available, so you can check from that option. So I have calculated this R20 value and R25 values, and this is the ampacity I get from the upper their catalog. I have got this value of the DC cables current in the ducts. These are in the ducts value. Right. So here I have applied the VLOOKUP formula. Most of you are know about the Excel. They have different formula available there, and I have applied the VLOOKUP formula. They will check this value from these tables and give us the response, and also the derating ampacity. I have given this. Now this criteria I have met that. I have make one tranche depth available, which is the sand which is covering the conduits, or it is 0.96 value, and the tranche depth I have 0.95 value. The ground temperature 30-degree 96 value, and factors for the circuit I have applied this one. So these are the total derating factors. You can amend as per your project requirement. At the end of the session, we have 2 days, separate days. I have to calculate all, like 200, 300 kilowatt or 1 megawatt system. We will calculate, make the uh, ground mounted system 3D layout on the SketchUp, then make a PVC, then we will calculate the cable sizing for that, and also the AutoCAD layouts for that. So these are the total derating factors, and they will, what they will check, they will, cable ampacity is this one, the derated, they will apply these derating factors, and they have give us that value. Now, what they will check? Now they will check this derated ampacity, this one. Basically, I have calculated the cable runs. Most of the cable cases, we have to increase the cable run. I have calculated the cable runs per phase. How? The, the ceiling is the formula that will give us the like the number value, not the decimal value. Number value, not the decimal value. So what I will do, I have just apply the maximum 336. This is the maximum basically this is the maximum current divided by the derated ampacity, and they give us the one decimal. So they will give us the decimal value one basically. This is the cable runs. Now what I will do, if we increase the cable 45 degree, if we increase the 45 load current, you can see that they have increased the cable runs per phases. So control Z. So they will calculate the cable runs, and I have multiplied the cable runs with the derated ampacity. Because the cable runs are the one, so that is why the derated ampacity and derated ampacity after cable runs per phase remain same. Now they will check the derated ampacity after the cable runs, because if we have two runs per phase, then the ampacity will derated ampacity will increase two times. So that is why I have checked the derated ampacity with the maximum criteria. This one as per the uh, short circuit as per the IC standard. So that is why I have checked this criteria, and this is the low side. So that is why they give us the true value for all the. And now other option is that now the derated ampacity formula is okay. Now we have to check the the other one, the voltage drop limitation. Now what I will do, I have the cable length available there. This one. Uh, for the voltage drop, we have the formula 2R. R basically we get from this value, the cable length and the current. But now one thing I want to clarify to you, all of you, when voltage drop, when it become the voltage drop, on which uh, I have a question to all of you, that for the voltage drop calculation, we have to apply which current, the operating current or the short circuit current? Anyone from you give me the answer. What current we will
Short circuit
apply
current.
for the voltage? Sorry,
Short circuit current.
Short circuit current, sir.
short circuit. Any other? Any other? Mr. Flax, Bakar, Mr. Yasir. What current we will use for the voltage drop calculation? I have question to all of you. Mr. Khurram and Mr. Mudassir has given me the answer, the short circuit. Mr. Yasir,
Sir, I didn't get your question. There is something. Your voice is breaking, and I didn't get what you are trying to say.
I'm saying that for the voltage drop calculation, the voltage drop formula is that 2RLI for the DC. What should be the value I it should be the operating current of the PV string or should be the short circuit current of the string? My question is that. It should be operating or it should be short circuit. Yes, Ismail?
I think it will be operating voltage, operating current.
Okay. Bakar? Give me answer. No issue. It should be wrong. No issue. Just give me your opinion. Mr. Flex? As per my experience, Mr. Khurram, Mr. Ismail, and Mr. Mudassir, and all of other, as per my experience, because the voltage drop is depend upon the the current which is in case of the operating. Because short circuit is only available when the PV modules is just open, and we check through the ampere meter. We will connect in the series and check the current when the panels are disconnected. But in case of the operating, the voltage drop will come there or happen. So that is why the voltage drop calculation is depend upon the operating current, not the maximum current. So that is why we apply the operating current, and I have applied this, and two most like toughest consultant has approved this values, the operating current, because as per IC standard they don't uh, specify that what current we shall use in case of the DC. But as per our experience, as per my discussion with a different consultant, the operating current will be used for the this criteria. Okay. So that is why I have applied the operating current, but it should be it should be the bifaciality included, not the simple one. So that is why I have applied this formula and divided by this the 1000, because 1000 is due to that the voltage the cable length in the meter, and in the formula the cable length should be in the kilometer. So I have calculated this voltage drop and then voltage drop percentage. The voltage drop divided by the string voltage. Now string voltage will come through the operating voltage. The operating voltage of the PV modules multiply with the number of PV module per strings. So from that we will give the answer of the string operating voltage, and I have divided this one, and you can see that now I have to check the criteria. I have applied the 1% voltage drop on the PV string side, and you can see that there are the 3 to 4 strings like there. This one, they are not meeting the criteria. So you can see that the cable should be on the higher side. But as per the IC standard, when we check that, and the average voltage drop is 0.69 criteria. So as per the IC standard, this will be allowable, because as per the IC standard, we have to give the every voltage drop is around 1 to 1.5%. but the maximum criteria, they are not satisfying that. So this is the string cable sizing. Now we move on to the LVDC cable sizing. They are almost the same one, but somehow some difference in available in that. Now, around PV modules, I have already explained. Now, I have calculated this one criteria. PV module per string 29, the same one which I have used in the string sizing. String operating voltage, same. PV modules voltage drop, voltage, operating voltage multiply with the number of strings. Then the string maximum current, it should be the maximum, this one short circuit by with including 10% bifaciality. Then it should be the string per combiner boxes. This is very important. When we are doing the LVDC cable sizing for the combiner boxes, we have to check that how many string we are connected to the one combiner boxes. They are in the changing phase, but as per one case study which I have prepared, in which I have considered the 14 string per combiner boxes. Now, the combiner box operating voltage remains same. Why? Now, another question to all of you. Why the operating voltage remains same like the strings in the combiner box? Why? Give me a short answer to all of you.
Sir, could you please explain the question?
I'm just saying that the string voltage is basically the multiple of the number of PV modules connected in one string with the operating voltage of multiply with the operating voltage of the PV modules. We get the string total voltage. Okay. Now, in case of the combiner boxes, we are connecting the 14 string to the one combiner boxes, and the operating voltage of the combiner box will remain same. Why?
Maybe it is connected by parallel, so
Because
that's
they are
why the
all
voltage
connected in
will remain the
parallel.
same and the current will be added.
Yes, that's
Because
great.
they
Now,
are connected with the parallel, because
yes, yes,
the voltage is the remain same
yes,
and multiplied by the volt amperes.
yes, yes. That's great. That's great. Because they are connected with each other in the parallel phase. The, the voltage remains same. The current, the operating current will become the multiple of the number of string, and with the maximum operating current of the PV module or PV string. And that is the maximum current, the short circuit current. Number of string per combiner boxes with the maximum string. And this is the IC criteria. As per IEC 62738, the combiner box are array. Combiner box are array. Subarray, sorry, subarray. Array current should be equal to ISC 10% plus 10% bifaciality, 25% extra margin, multiply with the number of string n. So it is basically, this is the formula. The combiner box or subarray current is basically IC plus 10% bifaciality, 10%, 25% extra margin, multiply with the number of things which are connected in subarray or in combiner box. Basically, combiner box act as a subarray. They are combination of, as per IC standard, they are combination of parallel combination of multiple number of strings. So this is the maximum current as per IC standard. Now moving on to the this portion. Same, I have applied the VLOOKUP formula for the R cable ampacity, and same criteria which I have already explained how we will basically R25 I get from the vendor data or IC standard for the 120, 150, 185, 240, 300, 400, 500, and 630 cables. And R25 I have calculated this cable R25. So there are some concerns as per these values R25, which three projects we have done. In that I have used the R25 cable resistance. But another consultant, which is ongoing project, they have raised the concern regarding the R25, and I have explained, and I have not received any comments till now. If I will get responses, I will share in the group one. But at that time, for the DC, we are using the R25, the standard test condition resistance, because as per IC standard, they don't give us the specific criteria for the R90 for the DC resistance. But for the Mr. Mudassir, I will give you the answer at the end of class. Okay. And these are the ampacity I will get from the their catalog. So here I have applied the same formula, VLOOKUP formula, that one, and I have checked this derated ampacity. With that, the derated ampacity basically I will get from these derating factor for the soil resistivity, depth, the ground temperature, and grouping factor. So that I have get that value, and now you can see that I have applied the size as a 500 for the single run. But if we go to the 400, then the cable runs will be become 2, because the criteria which we are the derated, this criteria, the derated ampacity, because we have to check that the 300 310.6 value. So they will become the 2 runs per phase. But if we use the 500 cables, it will become single runs per phase. And the voltage drop criteria I have given as 1.2%, and all the cables are satisfying that criteria. So that is the LVDC cable sizing. Criteria is same, the voltage drop and the ampacity criteria. And in the first class, I tell all of you that how we will calculate the number of runs per phase, and I have explained that the derated total load current, the total load current divided by the derated ampacity, we get the number of runs per phase. I will write down there, right here, for your information, because I will sharing this sheet in the group. Load current divided by derated ampacity. Ampacity. Okay. So that is all for today. Now everyone should raise the hand, and I will give the answer one to one. Yes, Mudassir. Now,
Sir, which type of cables you were telling us? R25 maybe or R90 maybe? Could you please tell me what is the type of this cable?
basically, it is armor cable. Armor cable. XLP slash PVC slash AWA, because it's a single core cable, and it will be armor cable, and the sheet will be also PVC or LSZH, the low smoke zero halogen cables.
Zero halogen.
It as per the yes, zero halogen. Because in the international level, in international market, most of the consultant and the client will require the low smoke halogen free cable. Why we take so serious on short circuit current? Uh, Kuram, as per your question, why we should take so serious on the short circuit current? Because as per the IC standard, they will, as per the IC standard, they will more emphasize on the short circuit in case of uh, derated ampacity criteria satisfying. Because if we have to size properly as per the IC standard, we have to apply the IC standard formulas, and international client and consultant will not accept this criteria. And some other point I will tell you in the thermal assessment calculation, another criteria which we have to follow. Yes, Khurram, yes, bifaciality works from the back side of the PV module. What is my mean by R20, R20? Basically, R20 and R25 means the DC resistance of the cable at 20 degrees centigrade temperature at R25 degree centigrade temperature. Yes, Khurram? Yes, Mudassir.
Sir, R25. I'm asking about R25.
Yes, sir. R25 means the DC resistance at 25 degree temperature. Basically, I have tell all of you that it is not a standard requirement which resistance we will use, but they mentioned that as per the vendor data, our vendor, they are give us the formula for the voltage drop. They are using the 20 degree centigrade temperature DC resistance. But some consultant or international client raised the concern regarding that point, and I have applied the R25 degree, and most toughest consultant. One is the Zutari, and the other one is the Usi Global. One is from the South Africa, and one is from the Middle East side. They accepted the R25 degrees temperature resistance, but as per the some other concerns, um, some experienced guys say that we have to use the R90 because the maximum temperature of the cable is 90 degree. But they are in between, not a, like I can say that 100% sure that which resistance we have used. But as per my experience, we have the used the R25 degree.
Sir, basically, what is the
Yes.
what is the standard condition with respect to Pakistan? If you talk about Pakistan, so which type of fabric do we use in Pakistan?
Regarding the resistance,
Yeah.
in Pakistan, you should use the R25, R20, not the R90. They don't bother about that.
Okay.
Yes, Khurram, 10% mean the bifaciality basically. As per the vendor, they give us the 80% bifaciality. Mean the but 10% increase the production means that the 10% bifaciality we have to increase the overall power of the PV module at the standard test conditions to 10% as in case of the bifaciality factor. Yes, Vakar, the efficiency of the PV module, I will be explaining in the next week, which is related to the data sheets of the PV module and inverter. I will explain the efficiency and how we will calculate. I will explain, but in the next week classes. Mr. Flex, Mr. Flex. Okay, Mr. Vakar. Everything I will explain as per my experience and my knowledge. I will try to explain every point, but they will take time because we have now almost 2 weeks remaining in the session, and every day I will try to give you the next and try to give you the best experience. Yes, Kuram, cable ampacity is very important because when we are sizing the cable, we have to give the and check from the vendors, and also as per the IC standard, they give us the ampacity of the cable. So ampacity of the cable is very important, and also the sector on which this ampacity is calculated. These are also very important. Mr. Bakar and Khurram, if you have any questions, you can ask me in Urdu if you are not satisfying in the English, but writing will take time. So kindly ask me the question and I will give you the answer. Khurram, we consider ICI. What you mean? I'm not getting your point. Khurram?
Sir, my question is this: we should use IEC standard or standard operating, which is 25 degree. Both are good, or only use the 25? Which is the best standard?
Basically, IC standard is giving the criteria. They give us the R20 R20 degree resistance, and also they give us the formula that
मैं कहना मैं फोन तो लगा
उर्दू में पूछ लें कोई मसला नहीं. I'm saying that IC standard, these are given us the resistance R20 and R25 formula or other value at temperature. We have to calculate the DC resistance. They give us the formula. The standard condition are basically the conditions on which the PV module give us the maximum output. These are the standard conditions for the PV module. IC standard is different thing, and the standard operating condition of the PV module, they are the different things. So I think you are interlinking with each other. But as I have explained that we should use, if you are sizing the cable in the Pakistan, you should use R20 R25 maximum, not more than that. Yes, Vakar. Mostly in the string cable sizing, we use a 6 mm, or some of the either cases we use a 10 mm. But for the LVDC, we should use the 16, 25, 35, 50. They go above for the LVDC cables, because here the current is become the sub array. Current is much higher side. So that is why we use that higher cables. But for the string, it mostly use a 10 or 6 mostly, because the MC4 connector which we are using, they don't allow us the 16 mm cables. They only give us the value up to the 10 maximum.
Sir, as per IEC standard, how much voltage drop is acceptable?
For the DC string, DC cables, it should be 1 or 1.5 average basis. IC standard
So if
62738, it should be
okay,
1 to 1.5% average basis as per IC 62738.
okay, sir.
But you all know that in Pakistan, mostly DC string they are using for the the small building cables. The voltage drop in on the higher side. They don't care about the voltage drop. But if you apply the proper cable sizing, uh, we have to use like somehow in between, or we have to use decrease the length, or we have to increase the cable sizes. Mostly you see that in Pakistan 4 mm cable is used. Okay, guys, I think it's all about. Yes, Bakar, if you have question.
No, sir. I don't have any question right now.
Okay, thank you, everyone. We will end by today class. Inshallah, we will meet it by tomorrow. Thank you, everyone, for joining the class.